Hi guys. So I thought it might be helpful to actually see some of these worked out, particularly the questions that I've put on the quiz, because they are complex in ways that the feedback videos aren't particularly addressing. So let's take, for example, testing that functions are inverses when we're looking at f of x equals sine of x plus 1 and g of x equals 1 minus inverse sine of x. So we're looking at those two functions. If we want to test that they're self-inverse, we do have to do it both ways. So we have to hope. This is what we're hoping for. This isn't what we've proven yet. We have to hope that f of g of x equals x, and we have to hope that g of f of x equals x. Like that. Okay? So that's what we're hoping for, both of those statements to come out true. If one of them doesn't come out true, then these are not inverses. If they both come out true, then these are inverses. So let's start off with f of g of x. We've got, that means that we're taking the g function and we're putting it in the place of x in the f function. So f of x is normally sine of x plus 1. But instead of x, we're going to replace it with the entire g function. So it's going to be 1 minus inverse sine of x. Okay, so we've got that expression so far. Now, you can't... Yeah, so because this part right here would technically be in brackets, but this plus 1 is still positive 1. It's just positive 1 minus inverse sine of x, and then positive 1 there. So when we combine these two terms, it's actually 2. It's positive 1 plus positive 1. So what we've got here is sine of inverse sine of x plus 2. Like that. Now, the value here, that's some particular angle that would give us a ratio when we put it in the sine function. If we wanted the ratio to come out as x, because think about this internal function right here, inverse sine of x, that means x is a ratio, and inverse sine would spit out an angle, right? If we wanted sine to produce the same ratio as x, we'd have to put the same angle in. So I'll give you an example, because that's a little... So let's look at inverse sine of a half. Okay, inverse sine of a half, I'll just do that on my calculator to double check what it is, but hopefully if you've been working on memorizing these, this is one of our special triangles. Inverse sine of 1 divided by 2, close brackets, is 30 degrees. Okay, now if we put 30 degrees in place of inverse sine of x, we've got sine of 32 degrees. Do you think that's going to be a half? Let's see. Sine of 32. Of course it's not a half. It's 0.5299 blah, 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 blah. Okay? 0.5299, etc. So you can see that if we put a different angle in, we get a different ratio out. If we put a different ratio in, we get a different angle out. And that's the issue right here. This is not going to spit out x because we've changed the angle by adding 2 there. So this one does not equal x. We can't simplify it any further than that. That's another way you could phrase it. So this doesn't simplify any further, so this one suggests that it's not an inverse because this statement is not true. Sad day. We'll test this one just so you can see how it might be a little nicer going the other way. Just in case you, I guess what I'm saying is, in case you worked it out that way first, let's see if you worked it out properly. So this time it's going to be 1 minus inverse sine of x, that's the g function, and we're putting into that the f function, so sine of x plus 1. Like that. Okay? Now in this one, it's actually quite interesting. Because you're applying the inverse sine and then immediately applying the sine. So you're putting an angle in, you're getting a ratio out, and then you're immediately getting the angle back. So this section right here does turn into x plus 1. The inverse sign and the sign cancel out because they're happening one right after the other. So this is 1 minus x plus 1. And now that we've got that, we need to make sure that we apply that subtraction to both terms within the brackets. So that's actually 1 minus x and minus 1. Some people like to think of it as 1 minus 1 times x plus 1. So then you're just applying the distributive property. You've got 1 minus x minus 1. And it's almost looking like it might come out to x, and you're going, is it an inverse? Well, no, because of that. But it doesn't actually come out to x. It comes out to 1 minus 1 is 0. Minus x is what you're left with. Sad day. So in neither direction is it an inverse, although one resembles an inverse much more closely. Beware.